Good afternoon everyone. So today I am going to talk about our project Swarm Robotics. So basically this project is based on like swarm intelligence, where number of robots are cooperating with each other and try to detect the required data, and then they send this data to a monitoring station. This particular project is really very good for places where no human can be deployed to measure the parameters. So this particular project can help us to gather the data in hazardous condition, for example in coal mines or maybe in deep jungles, etc.
For this purpose, we designed two robots using microcontroller Atmega 16. Both these robots would communicate using an RF module which works on 2.4 GHz of frequency, which is a free spectrum, which is an unlicensed spectrum. So it gives us an advantage. The master communicates with the slave using this RF module, and also the master communicates with the administrative robot using the same RF module, which works on the same frequency, but the baud rate is different in both cases.
The project is inspired by the creatures of the environment such as ants, bees, etc., which work towards a huge goal collectively, which would have been impossible for a single entity to complete on its own. So the challenge for us in this project was to build a prototype of two robots that can be extended or expanded for n number of robots.
So robot 1 will monitor air pollution, its area, and the same will be done by slave robot. Data from both these are made available to the master robot.
Collected from both the sensors, LM35 and MQ6 can be taken from both the robots, which can be displayed on an administrative machine for application purposes.
This is the full working configuration of our project. There are two robots, master and slave, that communicate with each other with the help of CC2500 RF module. So, as you can see on the slave robot over here, the different components are the LCD display, and you can see the data, that is temperature at 31 degrees C and gas at 31%. And there are these two sensors. One is MQ6, that is the gas sensor that tells us about the presence of gases like isobutane, LPG and other similar gases, and LM35 temperature sensor. So these two sensors are interfaced to the analog port of the Atmega 16, and the data, analog data, is processed by the Atmega 16 and converted to the digital form, and it is displayed on the LCD. And now this is a MAX 232 module, MAX 232. It can be used to communicate the data with the PC, because we need MAX 232 to convert and interface between the TTL logic levels of robot to the voltage levels in the PC. The other component that is over here is motor driver L293D. It is a motor driver, and we have used this to make our robot move in a prescribed path that we have hardwired into the robots. These two robots will monitor a particular area at some distance, and they'll achieve the communication. So, and the temperature and gas data are sent with the CC2500 RF module to the master. And as you can see, the temperature has just changed. The gas has just changed. Temperature is 31 and the gas is 29%. Now moving on to the master robot, functioning as a node where the data of both slave and master is being displayed and is collected. So coming on to the master robot, the basic components of the master robot are same, and as you can see, the LCD screen of the master robot has two rows. In the first row, the temperature and gas data of the first robot is displayed, master robot is displayed, that is 37 degree and 60%, as we had used the gas source agarbatti near the sensors, so the temperature and gas data of this has increased. And the second line that you can see, in it the data of the slave robot that has been communicated to it via CC2500 module is also displayed, that is 31 degrees C, and the gas data is also displayed. The additional component in the master robot is CC2500 transceiver module, which can operate at different frequency channels and different baud rates, which can be decided by the pins on its board. So which can be used to communicate the data of both the master and the slave to a centralized location that can be a laptop. As you can see, the laptop is also interfaced with the CC2500 transceiver module. That can be a future scope and further development can be taken. We have used the 232 12 volt step down transformers to give the power source to our robots. So the 12 volt AC signal, step down AC signal, is given to the robot via the transformer wires, as you can see. And then the output of the AC output is converted to the DC output via the use of bridge rectifier, and this 12 volt supply that is rectified is further regulated to 5 volt by the use of 7805 voltage regulator, and this is the power source of the circuit. As you can see, the LCD displays the data of the slave, that is 31 degrees C and 27% gas, which has now changed to 26% the gas concentration. This data will be communicated to the master, which will display the data of both master and the slave. So in this, the master acts as a node where the data of both slave and master will be displayed. You can see that the slave's line has been blanked out. As soon as the communication will be established, the data of slave and master will be displayed. Here the second line appears now.
Looking at this particular prototype of this project, we feel that there is a huge commercial potential in this particular project, and in future works we would like to develop this project further and would like to make a industrial product out of it. Thank you.